Welcome to the Corf tutorials. Today we will show how to manage a separation vessel. Let's assume that we have a pressurized mixture of methane and water entering a vessel at 500 kilopascals, and we want to remove condensed water from the pipeline. We will receive 85,000 kilograms per hour of the mixture, and we need to deliver the recovered liquid to a nearby tank at a pressure of at least 90 kilopascals. To model this system, we need a vessel, a control valve, one feed, and two products representing liquid and vapor outlets from the vessel. We will also need the correct flash method and add components to model the mixture. First, go to Tools, Options, and the Process tab. Ensure that SRK is selected as the Enthalpy method and enable the three-phase flash. Click OK. Next, go to the Process menu. Then select Components and use the search field to find water and methane, CH4. Add each component and click OK. Double-click on the first branch segment, L1, and remove the default pipe size to let Corf estimate the proper diameter. Change the length to 5 meters. Then go to the Flows tab and specify a flow of 85,000 kilograms per hour. Finally, click on Fluid to specify the conditions. Go to Composition and use 0.08 mol for water and 0.92 mol fraction for methane. Click OK to save changes to composition, and again OK to exit the pipe dialog. Go to the L2 and L3 pipe segments and remove the size but maintain the default length. Then, go to L4 and remove the size and change the length to 5 meters. Click OK. Next, click on the control valve and remove the CV specification. Click OK. Now is time to specify all pressures in this system. First, go to the feed F1 and change the pressure to 500 kilopascals. Click OK. Then, go to the vapor top product, TK1, and remove the pressure specification. Click OK. Finally, go to the bottom product, TK2, and change the pressure to 90 kilopascals. Click OK. At this point, the number of provided specifications are less than required specifications by 1, so we can't run the hydraulic simulation yet. Before adding the vessel specifications, remember that in Corf, a vessel can also represent a column or a tank. Apart from the drawing differences, all three are treated identically. Double-click on the vessel to open the corresponding dialog. The vessel pressure refers to the static pressure as measured by a pressure gauge at the top of the vessel, above all fluid levels. The information provided doesn't include any reference to the vessel pressure, so we can keep this field empty. However, we need to select the option for flows from HMB. This would count as a specification and allow us to run the simulation, but more importantly, it would instruct Corf to split the phases in the vessel according to the flash calculations. As a result, Corf would use the composition provided for L1, perform the corresponding flash calculations to determine conditions and liquid fraction, and pass this information to the vessel to specify liquid and vapor outlet flows. Corf allows to specify levels, pressures, and relative elevations for each nozzle in the vessel. Therefore, if mechanical drawings are available, the geometry of the vessel can be included in the hydraulic calculations. Note that elevations can be positive or negative, and the reference is the bottom tangent line. Pressure drops can be positive or negative as well, and the reference is the gauge pressure at the top of the vessel. Click OK to exit the vessel dialog. Then, click on the H and H button to run simultaneously the hydraulics and the heat and material balance. Note that if only the hydraulics is run, Corf treats vessels similar to mixers or splitters. In other words, the outlet flows would depend on the pressure drop calculations, but the user has to provide each phase. Running H and H will overwrite compositions and properties, so accept the warning. After a few iterations, Corf will find a solution for this system. Click on Results and select Flow from the Flows tab. Then go to the Equipment tab and select Equipment Pressure, Pressure Drop, and Valve CV. Click OK. At this point, you can verify that Corf has correctly used the composition to calculate the vessel outlet streams. You can observe that the feed segment has liquid and vapor flow, but each outlet only has one phase. Corf considered all the specifications and calculated a system that delivers the required flow at the specified conditions. Congratulations! Now you know how to manage vessels and how to specify conditions for heat and material balances.